Good evening, children.
Good evening, ma'am.
Children?
Good evening, ma'am.
Good evening. Good evening.
Good evening.
So some more students have to join us, but I think it's time we need to start the session. All right, children, as I had texted you on WhatsApp, this is the chapter we are going to start off with. Pair of linear equations and two variables. And I had also shared the introduction material with you. I hope all of you finished writing this in your notebook. Have you all done it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Kindly follow the instructions given on WhatsApp or in the classroom perfectly. Let there be no mistake or no delay in executing the instructions given in the classroom or on WhatsApp. All right. Okay, so let me not begin by asking you questions. Let me just recall, certain terms which we have already come across in standard 9. Okay, so let's recall the definition of the term polynomial. Okay, because this chapter is about linear polynomial, linear equations in one variable and two variables. So let's begin by recalling the definition of this term polynomial. So this was the second chapter. In standard 9, this was the second chapter, polynomials. Let's recall the definition. So a polynomial is basically an algebraic expression. A polynomial is an algebraic expression, or you can simply say an expression. You can simply say an expression. Okay, an expression in which the variables involved, the variables, what are the variables? X, Y, Z. Okay, so an expression in which the variables involved are raised to non-negative integral powers. Non-negative, let's recall what this phrase means. Non-negative integral powers. Okay, non-negative integral. Integral means of integers. Integral powers. An expression, we all know what an expression is. Something made of X, Y, Z, numbers, plus, minus, sign, and all that, is an expression. An expression in which the variables involved are raised to non-negative integral powers is called a polynomial. So now, when you take this example, 3x squared minus 4x plus 5y, say minus 7/2. This is an algebraic expression. See, to understand whether it is an algebraic expression or not, you don't have to think much. You can see some numbers there. You can see variables x, y. You can see that the terms are connected by plus minus sign. It's an expression. It's an algebraic expression. What you see on the screen is an algebraic expression.
Okay, ma'am.
I've shared my screen. I hope it's visible for all of you.
Yes, ma'am.
I've shared my screen. Right now you cannot see it. Now you can see it. Yeah. I hope my screen is visible to all of you in the classroom.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, so just for your kind information, I've shared my screen. All right. So the example which you see there is an expression, is an algebraic expression. Now this algebraic expression is also a polynomial because the variable x. Okay, now before that, non-negative integral powers, meaning whole numbers. whole numbers. The phrase non-negative integral powers means whole numbers. Because non-negative, see on a number line, we have 0, we have negative numbers, we have positive numbers. When we say non-negative means it's not negative. That means it can be 0 and positive. See on a number line, we have 0, we have the negative numbers here, we have the positive numbers here. And when we say non-negative meaning it's not negative. Non-negative meaning it's not negative. It's not negative. Okay, it's not negative. That means what is remaining? 0 and positive. That means what do you call 0 and positive values? And see, it's integral, meaning of integers. So it's not fractions here. Non-negative meaning 0 and positive. 0 and positive what? Integer powers. Integers meaning 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What are integers? Integers. Now 1 by 2 is not an integer. Integers are so positive. So basically 0 and positive integers. Take out the negative one. So basically 0 and positive integers. So 0 and positive integers are +1, +2, +3, +4, which makes whole numbers. Integral is of integers, integer powers. The integer power, it can be any integer power, but it should be non-negative. That means it can be 0 or positive integers, which means they are whole numbers. So the phrase non-negative integral powers means whole numbers. So simply remember whole numbers. So here the power of x, variable is x. The variable is x, its power is 2. It's a whole number. The variable x, its power is 1, whole number. Variable y, power is 1, whole number. So the variables involved in this term, the variable is x, its power is 2, which is a whole number. In this term, the variable is x, its power is 1, whole number. In this term, the variable is y, its power is 1, whole number. So you can see here that the powers involved are all whole numbers, and hence the given or hence the expression there is a polynomial. It's a polynomial in two variables, x and y. And further, if you can recall, it's quadratic because the highest power is 2. It's quadratic. It's quadratic in two variables, x and y. Okay, so this was just to recall what we mean by a polynomial. So in an algebraic expression, let's take some more algebraic expressions. So now suppose we say okay, so the variable here, the variable is x, power is 4, whole number, x power 3. Don't see the coefficient. We're not looking at the coefficient, we're looking at the power. Variable x, power 3. 3 is a whole number. Variable x, power is 1. 1 is a whole number. So the variables involved, the powers of the variables involved are all whole numbers. And so this expression is a polynomial. Now, when we say linear poly, so this is about a polynomial. Algebraic expression is a polynomial. An algebraic expression is a polynomial only if the variables involved are all raised to whole numbers as their powers. Okay. Now, when we say a linear polynomial, let's write an example of a linear polynomial in one variable x. Let's write an example of a linear polynomial in one variable x. Okay, one variable, only one variable x should be there. Okay, and it should be linear. So like 3x minus 7, polynomial. You should not write is equal to 0 because we're not talking about a linear equation. When you equate it to 0, then it's an equation. It's a polynomial. So it's simply, there should only be that expression. A polynomial does not have an equal to sign. Okay, so 3x minus 7. 3x minus 7 is an algebraic expression. It is also a polynomial because the variable x is raised to the power 1. It's a polynomial, whole number, no? 1 is a whole number. So it's a polynomial. Now there's only one variable x. And it's linear because its power is 1. Recall from standard 9, when the power is 1, it's linear. When the power is 1, it is linear. And there's only one variable x. So this is a linear polynomial. This is a linear polynomial in one variable x. In one variable x. I repeat, 3x minus 7 has only one. This is an algebraic expression. It is an algebraic expression. There's only one variable x. And this algebraic expression is a polynomial because the power of x is 1, which is a whole number. It is a polynomial. And it's a linear polynomial because the power of x is 1. So it's a linear polynomial. So 3x minus 7 is a linear polynomial in one variable x. Now to generalize this is a specific example. This one is a specific example of a linear polynomial. But there are so many, you can give so many examples like this. So how do you generalize an example? So to generalize, this number 3 can be represented by a. X is the variable, so that will come as it is. The sign can be plus or minus. So in general, we say plus. Now this can be written as 3x plus of minus 7. That's what it is. OK, so let me write it like this and explain. So you can write 3x minus 7 as 3x plus of minus 7. This is 3x minus 7. All right. So the variable x as it is. Now this 3 can be taken as a in general. A. X is the variable x as it is. This plus as it is. And minus 7 can be b. So ax plus b. Ax plus b is the standard form of a linear polynomial in one variable x. Ax plus b. So how did we write ax plus b? Let's take another example and understand the same thing. So I was telling you now, supposing 5x minus 4 by 5. All right. So this can be written as 5x plus of minus 4 by 5. So now to generalize this is a specific example of a linear polynomial in one variable x. One variable x, it's a polynomial. It's a linear polynomial because the power of x is 1. Now we generalize this like this. X is the variable, write it as it is. 5. So let it be a plus and this one b. So ax plus b is the standard form of a linear polynomial in one variable x. Now talking about a linear polynomial, now when you equate this to 0, it's called a linear equation in one variable x. Ax plus b is the standard form of a linear polynomial in one variable x. When you equate this to 0, this is the standard form of a linear equation in one variable x. Now, an example of a linear polynomial in two variables x and y. Let's see that. An example of a linear polynomial. See, every term has a meaning, you know. So we are saying linear polynomial in two variables. So normally we take x and y as the variables. Linear polynomial, see, linear meaning the power of the variable should be 1. The highest power should be 1. OK, so linear meaning the highest power of the variables involved should be 1. Polynomial. We just understood what a polynomial is. So linear polynomial in two variables x and y. Let's write an example. Say 3x minus 4y plus, whatever, say some root 5. I shouldn't say is equal to 0 because we're talking about a polynomial, not an equation. We're not talking about an equation. We're talking about a polynomial. So this can be an example. 3x minus 4y plus root 5. Now, how is this an example of a linear polynomial It is a linear polynomial because it's first a polynomial because this is the variable whole number power. This is a variable whole number power. So it's a polynomial. The powers are whole numbers. WHOLE, whole numbers. You know what whole numbers mean? I've been using the term. I've used that term so many times in the class. I hope it's clear. Whole numbers. So X variable, whole number power. Y variable, whole number power. So it's a polynomial. It's linear because the highest power is 1. So it's linear. And it's 2 variables because you can see 2 variables X and Y. Now somebody volunteer, give me another example. Now see this root 5, this can be anything. See what defines a linear polynomial in 2 variables X and Y. Can we see 2 variables X and Y? Yes, we can see. Is it linear? Yes, it is linear because the highest power is 1. So it is linear. And it is a polynomial. It is a polynomial because the powers are all whole numbers. Yes, one more example. One more example of a linear polynomial in 2 variables X and Y. Class.
Can I?
Yes, please.
2x plus 3y plus 5.
Plus 5. Should I say is equal to 0?
No, ma'am.
No. What happens when I equate it to 0? What do you call it when I equate it to 0?
Plus it becomes linear equation.
Continue, complete it. It becomes a linear equation in
2 variables.
2 variables. Complete. 2 variables.
X and y.
X and Y. Yeah. When you say is equal to 0, then it becomes a linear equation, not a linear polynomial. It becomes a linear equation in 2 variables X and Y. So for now, we are not saying equal to 0. However, you can understand that. When you say equal to 0, it becomes a linear equation. That's it. In 2 variables X and Y. All right. So let's generalize this. So this can be another example of a linear polynomial. See, when you every word you utter, you should understand what it means. Only then the entire thing makes sense to us. Okay, so this is an example of a linear polynomial in 2 variables, X and Y. Let's generalize this. So X is the variable. You cannot write X as something else. X is X, but this 2 can be any number. So A plus this can be B, and this Y is a variable as it is, plus C. So AX plus BY plus C. AX plus BY plus C is a standard form of a linear polynomial in 2 variables X and Y. There are the conditions. I didn't tell you the conditions. We'll come to that. So now what you have understood is when it is AX plus B, this is the standard form of a linear polynomial in 1 variable X. When you say AX plus BY plus C, this is the standard form of a linear polynomial in 2 variables X and Y. AX plus B is a standard form of a linear polynomial in 1 variable X. AX plus BY plus C is a standard form of a linear polynomial in 2 variables X and Y. When you equate it to 0, it's called a linear equation in 1 variable X. When you equate this to 0, it's a linear equation in 2 variables X and Y. Now, the condition here is B can be anything. B can be any real value. B can be any value that exists. B can be any value, any real value, but A, can also be any real value other than 0. Because if it is 0, then it becomes 0x plus B, no? That means it's only B. So then it's not, where's the variable? The sensitive thing is the value of A. A should not be 0. Other than 0, it can be any real value, any number that exists. The coefficient of x, because if a is 0, the value of a is 0, 0x plus b. 0x is nothing but 0. So 0 plus b, which is just b. So that the variable x is gone. Then how can you call it a linear polynomial and one variable x? X itself is gone. Okay. So ax plus b. B can be any real value. A also can be any real value, but not 0. It should not be 0. It's very easy to remember. A can be any real value. It cannot be 0 alone because it then becomes 0x. Okay, other than 0, it can be any real value. It can be rational, irrational, can be root 5, root 3 by 5, 3 by root 5, whatever, but it should not be 0. A can be any real value, but not 0. B can be any real value, meaning it can even be 0, because this is also an example. When we say 3x, 3x is a linear polynomial in one variable x plus 0. Now you will ask me, then how was it ax plus b? 3x plus 0, ax plus b, where b is 0, x, a is 3. 3x is also a linear polynomial. 3x means 3x plus 0. Okay, so ax plus b, where a and b can be any real value, a should not be equal to 0. So that's what you would have seen here. Ax plus b, a and b are real numbers, but a should not be equal to 0. Ax plus b is a standard form of a linear polynomial in one variable x. A and b are real numbers and a not equal to 0. Ax plus by plus c, so that's the next thing. So ax plus by plus c. Now again, see, all this of 9th standard is important to understand this. We have again seen one more thing last year, that a linear equation in one variable x can also be treated as a linear equation in two variables x and y. We have seen this in the chapter linear equations in in two variables. Okay, what is the difference between the chapter we saw last year and this, what we're doing now? Class, am I audible? Is my voice clear to all of you in the classroom?
Yes, ma'am.
Okay. All right, children. So what was I telling you? Yeah, the difference between the chapter we've seen last year and this chapter, what is the difference? Okay, so last year it was. Okay, so last year it was a linear equation in two variables, linear equation in two variables. That means only one linear equation in two variables. Now this year it is a pair, two linear equations. Last year you saw only one like this. You would have seen only one and you would have made graphs for all that. So you had only one equation like this. 3x plus 5y minus 7 is equal to 0. Make a graph of this one. And you know that the graph is a straight line. It's a straight line in the Cartesian plane. We've also made graphs for the linear equations. So last year we dealt with only one linear equation in two variables x and y. Now we're going to deal with two linear equations, a pair of linear equations in two variables x and y. So last year we had only one equation. I'm repeating it. Last year we had just one equation like this. Okay, so what is this? It's a linear equation. It's linear because the power is 1. A linear equation. in two variables x and y. And only one equation like this you have. You have only one equation like this. Now this year you will have another equation, maybe like this. This is the other equation, say. This is the other linear. So this year we're going to deal with a pair of linear equations in two variables x and y, in two variables x and y. So last year, when you made the graph for this one, you have got a straight line. So straight line. Okay, so you plotted 3 points, you connected the 3 points. You would have been able to connect the 3 points by the same straight line and you obtain the graph for this equation. I'm saying for this equation last year. Okay, so when you try to put this on the graph paper, this equation on a graph paper, you had to make a table, you had to make an XY table, make an XY table. Okay, so give some values for X, find the corresponding values of Y, plot these points, plot the 3 points, connect the 3 points and get the straight line that represents this equation. So now this year when you do this, now for one equation you have one straight line. So this year we're going to deal with two equations simultaneously. So now this equation will be given by another straight line. When you make the graph for this equation, so for this equation you need to make another table, another XY table. Okay, you need to make another XY table. Again, give some values of X, find the corresponding values of Y, plot those points, plot those 3 points, connect the 3 points. You should be able to connect it by the same straight line because it will be a straight line. If you're not able to join the 3 points by the same straight line, somewhere, we have gone wrong in making the table. Because every linear equation in two variables is a straight line or is represented or can be represented by a straight line in the Cartesian plane. The Cartesian plane is the plane in which the x-axis and the y-axis lie. The Cartesian plane is the plane in which the x-axis and the y-axis lie. So on a piece of paper, okay, if you draw the x and y-axis, that is the Cartesian plane. That's the Cartesian plane. Your notebook becomes the plane. So I'm saying that last year we had only one equation like this in two variables x and y. And when we made the graph, we got one straight line. But this year we're going to have another equation. So you get another straight line. So this chapter is all about how two straight lines can behave in the Cartesian plane and finding their solutions. That's what we're going to see next. So that's the difference between the chapter which you saw last year and what we are doing now. See, I had this habit of repeating because I just want to make sure that all of you are getting it. Am I clear, children?
Yes, ma'am.
All right. Okay, so now we need to see the condition. Where are we? We're trying to understand the standard forms. So we just understood this ax plus by plus c is the standard form of a linear polynomial in two variables x and y. When you equate this to 0, it's a linear equation in two variables x and y. Now the conditions are very important. You cannot define it. You cannot write it without the condition. You have to mention the condition. So here the condition is, oh yeah, I was telling you this. So last year we've seen that before this I need to tell you this. We need to recall this. So last year we've seen that every linear equation in one variable x. Let me take an example. Now supposing we have this. Please children, so now this all depends on how much you can recall. Okay, so last year, see this one, how did you represent this? By a dot or by a point on a number line. Let me take something which I can plot. Now, when I say 3x, let me not take 3x. say, okay, 2x minus 11 is equal to 0. Okay, so what do you get on solving? 2x is equal to 11 by 2, or not 2x is equal to 11 by 2. Okay, so 2x minus 11 is equal to 0, 2x is equal to 11, x is equal to 11 by 2 or 5.5. So if you had to make the graphical representation of this one, we took up a number line and 0, 1, 2, 3, 4, 5, 6, and then this is 5.5, 5.5. So here we said x is equal to 5.5. Children, please recall this. This is how we represented a linear equation in one variable graphically. Graphical representation or the geometrical representation, graphical or the geometrical representation of a linear equation in one variable x. We just solve it and then we get the value of x, which is here 5.5, and we show its position on the number line. That's the graphical representation. .5 is between 5 and 6. Now the same equation, now a linear equation in one variable x can be treated as a linear equation in two variables x and y like this. Please recall this. A linear equation in one variable x. See here, 2x minus 11 is equal to 0. 2x minus 11 is equal to 0. Where is y? 0y. You cannot write y because y means it's 1y. So 2x plus 0y minus 11 is equal to 0. When you write it like this, you're treating the linear equation in one variable x as two variables as an equation in two variables x and y. 2x plus 0y minus, they're the same. 2x minus 11 is equal to 0 and 2x plus 0y minus 11 is equal to 0. Actually, they look like they mean the same. Let me say that. Algebraically, they mean the same. See, when 2x minus 11 is 0, 2x minus 7 is 0 because 0y is anyway 0. But their geometrical representations are different. When you treat it as an equation in one variable x, it's represented by a point on the number line. When you treat it as an equation in two variables x and y, it is a straight line in the Cartesian plane. Now for this one, when we do graphs, we'll again see. If you've forgotten how to make the graph for this, we will recall when we, come to that section of this chapter. That is towards the end of this chapter. How to make the graph. We'll see that later. So one variable, point on the number line. The same equation, if you treat it as a linear equation in two variables x and y, by introducing the 0y, then it is no more a point on the number line. It's represented by a straight line in the Cartesian plane. You can make a table for this, xy table for this. You can make an xy table for this, get the 3 points, plot and get the straight line. That is what is the representation of this equation. So what is the takeaway from this? We're trying to recall that every linear equation in one variable x can be treated as a linear equation in two variables x and y. Every linear equation in one variable x can be treated as a linear equation in two variables x and y. How? By introducing that missing variable. If x is missing, see here now here if x is missing now, if you have the, if the variable is y and you have 2y minus 5 is equal to 0, then that means 0x plus 2y minus 5 is equal to 0. Introduce that missing variable using the coefficient 0. So here you have y, so x is missing. So 0x plus 2y minus 5 is equal to 0. Well, this is represented by a point on the number line because only one variable, no, so point on the number line. But this one is a straight line in the Cartesian plane because we have two variables, x and y. So this can be the geometrical representation of this one is a straight line in the Cartesian plane. That means for this one, we need to make the xy table and get the straight line. And this one, how do we represent this? On solving this, you will get 2y is equal to 5. Y is equal to 5 by 2. When you solve this, you get y is equal to 5 by 2. And what is 5 by 2? Y is equal to 2.5. Where is 2.5? Where is 2.5? This is y is equal to 2.5. Okay. So that means in this example, what is the coefficient of x? It's not 0. What's the coefficient of y? It is 0. But still we say this is a linear equation in two variables x and y. This one is a linear equation in two variables x and y because you can see the variable x, you can see the variable y. But what if it is like this, children? If I write 0x plus 0y minus 11 is equal to 0, this cannot be regarded. There is no x, there is no y, there's only the constant. If there's one variable, you can introduce the other one by saying 0y or 0x. If there's nothing, you cannot write, supposing you have the number 11, you cannot write 0x plus 0y plus 11 is equal to 0. This is a linear equation in two variables x and y. No, both of them cannot be 0. That is a and b. See, this is ax plus by, right? Plus c is equal to 0. Both a and b cannot be 0. Both a and b cannot be 0. One of it can be 0. See, if you have the number 5, you cannot just put 0x and 0y before that, plus and is equal to 0, and you cannot say that now this is a linear equation in two variables x and y. Both a and b are 0. A is 0, b is 0. This is a constant. 5 is a constant. It's a constant polynomial. When you have 3x minus, okay, 8 is equal to 0, there is one variable x. So you can introduce the other one like this. You can introduce the other one like this. And you can, this is in one variable x. And this can be treated as a linear equation in two variables x and y like this. So that means both of them should not be 0. One of them can be 0. One of it can be 0. That is what is the meaning of a square plus b square should not be 0. Now, since there's too much of explanation, I'll not take a long time to talk about this. We'll see this in the next class. That's just because I don't want to dump something in your mind, you know. As of now, just take this light, okay? We'll just take it up in a class where we have not much of theory to understand. In a practical session, I'll tell you how to understand this very clearly. For now, you just take it like this. A square plus b square not equal to 0 means a and b both should not be 0 at the same time. That's the meaning. I can explain that to you, but I'm saying not in today's class. It may become too much. Okay, so now that's what it is. This is the standard form of a linear polynomial in two variables x and y. A, B, C are real numbers, but A and B are not both 0 at the same time. That is, if A is 0, B should not be 0, or if B is 0, A should not be 0. That is the meaning of A square plus B square is not equal to 0. A can be any real number, B can be any real number, C can be any real number. A, B, C are real numbers. A, B, C are real numbers. And how do we write it like, how do we express this mathematically? That is, express what mathematically? A and B are not both 0 at the same time. That is, if A is 0, B should not be 0. If B is 0, A should not be 0. How do we represent that mathematically? So we say a square plus b square is not equal to 0. A square plus b square is not equal to 0. I told you I'll explain this in the next class. So here also, here a, b real numbers, a should not be 0. Here a, b, c real numbers. If a is 0, b should not be 0, or b is 0, a should not be 0. A and b should not be both 0 at the same time. AB can be, see, ABC can be any real value. They can be anything. But when it comes to 0, both of them should not be 0 at the same time. A and B should not be both 0. Either A is 0 or B is 0, but both of them are not 0. Okay, these are the conditions. So these are the standard forms. These are the standard forms. Standard forms. It's very easy to understand. If you forget, you just take an example. If you forget the standard form, there's nothing to memorize. Just write an example. Just write an example. Like this, you write an example. This is a linear polynomial in one variable x. So make this ax and don't say minus. So this is treated as, I told you this, 2x plus of minus 5. So ax plus b it is. That's all. Take another example. Two variables x and y. Two variables x and y. Let me take a plus sign because you know you can write a minus as plus of minus. Can be written as 2x plus minus 3y plus minus 5. So what's the standard form? A x plus, this is b, this is y as it is, plus c. The coefficients become a and b and the constant becomes c. That's all. Just take an example and get the standard form. No big deal in remembering this. You take all with positive values to get the standard form. Just write like this. There are two variables and it's linear. So standard form will be 2 is ax plus this 3 is by, and this 5 is c. Y, x and y as it is, they are the variables. X and y are the variables. So this is a standard form of a linear polynomial and two variables x and y. Conditions a, b, c real. A and b should not be both 0 at the same time. That's all. That's what you see here. That's what you see so far. And I told you this, when a linear polynomial is equated to 0, it is called a linear equation. So that means when this is a linear polynomial, you equate it to 0, it's a linear equation. This is the standard form of a linear polynomial and two variables x and y. Equated to 0, it's a linear equation. When these are equated to 0, they are linear equations. This one is in one variable x, this one is in two variables x and y. Okay, so that's what it is till here. All right. And we also just recall this. Every linear equation in two variables represents a straight line in the Cartesian plane. And every point on the line is a solution to the equation. We saw all this last year. Every point on that straight line, is a solution to the linear equation. A linear equation in two variables is a straight line in the Cartesian plane. And when it's a straight line, there are infinitely many points on it. This class will be entirely theoretical, children. So maybe we can start off with the, solving part from the next class. Please listen carefully. Okay, so every point on the straight line is a solution to the linear equation. So now, when it's a straight line, how many points are there on the straight line? Infinitely many points. So that means a linear equation in two variables has infinitely many solutions. We've seen again. Why am I repeating? We've seen it last year, because you shouldn't think that I'm not explaining it clearly. So all this is a recall from last year. When it's a linear equation on two variables, it's a straight line in the Cartesian plane. How many points are there on the straight line? Infinitely many points. On the straight line, how many points are there? Straight line, infinitely many points. And every point is a solution to the equation. So since a straight line has infinitely many points, a linear equation in two variables has infinitely many solutions. Because every point on the straight line is a solution to the equation. This is the graph. So it's a straight line. So many points. Every point is a solution to that linear equation. Supposing this is like some 2x minus 7y plus 3 is equal to 0. Supposing every point, now this point has an address, 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 every point has an address. Every point is a solution to this equation. Now, how many points are there on this number line? Oh my, so many points, infinitely many points. So if there are infinitely many points on this line, this equation has infinitely many solutions. Because every point is a solution to the linear equation. So that means a linear equation in two variables x and y has infinitely many solutions, because on the straight line there are so many answers. On the straight line there are so many points. Every point has an address and every point is a solution to the linear equation. For this reason, a linear equation in two variables has infinitely many solutions, because on the straight line there are so many points. There are infinitely many points. That's what is explained here. Since a line has infinitely many points on it, every point is a solution to the equation. For this reason, a linear equation in two variables has infinitely many solutions. A standard form of a pair of linear equations. Now we're coming to the chapter. Coming to the chapter meaning the title, understanding the title. So what is the title? A pair of linear equations in two variables. This is the title. So let's write two equations, okay? Let's write two equations. So some 2x plus 3y minus 7 is equal to 0. And something like 5x plus 6y minus 13 is equal to 0. See, children, minus 7 can be written as plus of minus 7. So let me take a positive one only. When it's negative, you can write it as plus of the negative value. Let me just take a plus is equal to 0. So now tell me. Now this is AX, right? Correct? Class, please respond.
Yes, ma'am. Yes.
Okay, 1 minute. This is one linear equation. This is one linear equation on two variables x and y. This is another. This one is another equation, another linear equation on two variables x and y, correct? Can we see two examples? Or we can see two examples. Yeah, we can see two examples. That is, we can see a pair of linear equations in two variables x and y. Okay, so now when you take both of them simultaneously, what will you call as ax plus by plus c is equal to 0? What will you call this one? Same thing, ax plus by plus c is equal to 0. Then how will you differentiate between the two when you're taking both of them at the same time? When you take one linear equation at a time, you can say ax plus by plus c is equal to 0. But we will be dealing with two equations at the same time. You cannot call both ax plus by plus c is equal to 0. Correct. I heard it right. So x and y, don't disturb x and y. X and y are the variables. Don't write x1, y1 because the variables are not x1, y1. The variables are x and y. So differentiate the coefficients. Call this a1 call this A2. Call this B1, call this B2. Call this C1, call this C2. Simple, right? So A1X plus B1Y plus C1 is equal to 0 and A2X plus B2Y plus C2 is equal to 0 is the standard form or represents the standard form of a pair of linear equations in two variables x and y. A1x plus B1y plus C1 is equal to 0 and A2x plus B2y plus C2 is equal to 0 represent or is the standard form of a pair of linear equations in two variables x and y. Now, what are the conditions? A1, B1, C1, any real number, real value, all can be real numbers. Similarly, A2, B2, C2 can be real numbers. But the important condition is in this equation, A1 and B1 should not be both 0 at the same time. And in this equation, A2 and B2 should not be both 0 at the same time. See, two conditions. One is A1, B1 and C1 can be real values. Here A2, B2 and C2 can be real values. The other condition is in the first one, in the first equation, A1 and B1, both of them should not be 0 at the same time. That means A1 square plus B1 square should not be equal to 0. Similarly, the second equation, A2 square plus B2 square should not be equal to 0. That means both A1 and B1 should not be 0 at the same time. If A1 is 0, B1 should not be 0. Or if B1 is 0, A1 should not be 0. Same thing for A2 and B2. If A2 is 0, B2 should not be 0. Or if B2 is 0, A2 should not be 0. Which means A2 square plus B2 square should not be equal to 0. So these are the conditions. And that's what you see in this slide. Standard form. See A1x, B1y plus C1 is equal to 0. Real values, real numbers, not equal to 0, not equal to 0. That means, I told you, let me not repeat it. I told you what it means. So now we have two equations. That means two lines will get in the Cartesian plane. Now we have two equations, right? One equation, one straight line. Two equations, then two straight lines in the Cartesian plane. Now, how will these two lines behave? How or what are the possible, ways in which these two lines can behave? What are the possibilities of these two lines in the Cartesian plane is what we're going to understand next. All of you can use the raise hand option to raise your hand. Please use the raise hand option. Raise your hand, class. Nivedita, Nikita, Shreyas, Kanishka, Hitesh, Murali, Deepika, Pranav, Ananya, Tarun, Meera, Nandini, and Pranav. Pranav has logged in from two different devices, is it?
For me, computer. Ma'am, mic didn't work, ma'am.
Okay. I'll let you know. Very good. All right. So now we have two equations. So how will their graphs behave in the Cartesian plane is what we want to see now. Cartesian plane. One equation, you will get one straight line. Another equation, another straight line. Now, how will that other straight line be? Or how will the two straight lines? What are the possible ways in which these two straight lines can behave in the Cartesian plane? So we say that the two lines can be parallel to each other, or the two lines can intersect, or the two lines will be coincident, That is, one line lies on the other line. The other line also lies on the same line. So the two lines can be intersecting lines. The two lines can intersect each other in the Cartesian plane. See, It's not that they should make a perfect X like this. See, like this is your graph paper. So maybe one line is like this and the other line goes like this. So they intersect. The two lines, because you have two equations, right? You have two equations, so you'll have two straight lines. The two straight lines may be intersecting lines like this. Or if they don't intersect, then maybe they're parallel to each other like this. When you make the graph, maybe the two lines are parallel to each other. Okay, if they're not parallel, then the only other possibility is they're coincident. Like you plot 3 points like this, 1, 2, 3 points like this, and you get the straight line. All right. Now, when you plot the other 3 points, they'll also lie on the same line. When you plot the other 3 points for the other line, they'll also lie on the same line. So when you try to connect it, it'll be the same line. That is all the 6 points. You have two equations, right? So you would have made two tables like this. And when you plot the points, the 6 points, you will see that all the 6 points lie on the same straight line. That is, the two lines are coincidental. Coincident lines. So these are the only two possibilities. You cannot think of anything else. Now, you might think of this. You might think, what if my lines don't meet? One line is like this, the other line is like this. They don't meet. They are lines. So see, when you produce them, they will meet somewhere. When you produce, they'll meet somewhere. Maybe on your graph paper, they don't meet. See, like when you make the lines, so our graph paper is confined to that page. So maybe when you make so the first equation, when you make the graph, say you get the line like this. Okay, and the second equation, when you make the graph, you get a line like this. Now you will say, see, these two lines, they don't meet. No, but they're lines. They're not line segments. So when you produce it, you can produce it. See, they meet here. So they're intersecting lines. Parallel lines means they'll not meet at all, even if you produce them. Even when you produce them, they'll not meet. They are parallel lines. So the lines can be intersecting lines, or they can be parallel or coincident lines. Coincident lines meaning when you plot the 3 points of one equation and the 3 points of the other equation, you will see that all the 6 points lie on the same straight line. That is, when you connect it, you will get the same line. You want to get 2 lines, but you're not getting 2 lines. Both are the same. One line lies on the other line. So coincident lines. So these are the 3 possibilities. So that's what you see here. Graphically. Okay, so graphically, a pair of linear equations and 2 variables. A pair, that means 2. 2 variables, 2 equations. 2 variables x and y and 2 equations is represented by 2 straight lines in a Cartesian plane. Then we have only 3 possibilities. How will these 2 lines behave? We have 3 possibilities. The 2 lines intersect. The 2 lines are parallel. The 2 lines are coincident. These are the only 3 possibilities. So this is one information. How the 2 lines can behave. They can either intersect each other, they can be parallel, or they lie one on the other. They're coincident. Nothing else is possible. You can think about it. They cannot be anything different from any one of these 3. Okay, now coming to how to find the solutions for a pair of linear equations in 2 variables x and y. How to find the solutions? See, this is one info. This is over. It's not a continuation. All right, this is one information. That's over. Now the next one. How do you find solutions to a pair of linear equations in 2 variables? So we have the methods. We have the algebraic method. We have the graphical method. Graphical method, as I told you, we'll see at the end of this chapter. So we'll first start off with the algebraic methods. In the algebraic methods, we have, the elimination method, substitution method, and cross multiplication method. But we have one other method which is called the special method. We have one other method which is called the special method. We'll see that. So we have two ways of solving: algebraic, graphical. Algebraic is like working. You work, you solve it. Graphical is using the graph paper. So you can find solutions to a pair of equations in these two ways. Any questions, children?
No, ma'am. No, ma'am.
Kanishka, you joined late. Your mom informed me. Are you able to follow?
Yes, ma'am. Yes, ma'am.
All right. All right, children. So these are the two methods. And as I told you, under the algebraic method, we have these three methods. Under the algebraic way of finding the solutions, we have these three methods. Okay. Now, this is about. Now, let me just give you some time. I'll just not a break but let's just keep quiet for some time before I proceed with the. It doesn't happen always like this when it is completely theoretical, Now, you have to read all this information again. See, nobody will ask you to write this theory, but it is important to have this theoretical knowledge so that the chapter is clear to you. I cannot directly jump into the exercises without this introduction. So now that you've got the explanation, please read. Now, the other day meaning I think yesterday I shared it with you. Yeah. So yesterday or today when you wrote out all this in your tuition notebook, it wouldn't have made much sense. And you would have been wondering why I had asked you to write it, because now in the class to write all this is time consuming. I can't make you write this in the class. We'll solve problems in the class, but theory will be shared with you. And theory comes only once in a way when we start a new chapter. Otherwise, nothing regularly will be shared like this to be completed in the notebook. Mostly when we start a new chapter, and if there's a lot of theory attached to the chapter, I try to share it before so that you can complete that in the, before, you can complete it not during the class, but before the class. When you wrote this, maybe you did not understand. So now read this information. Now you have all this in your notebook. Read all this slowly. Yeah, read all this very slowly. If you read it fast, a polynomial of degree 1 is called a linear polynomial. Ax plus b is a standard form. See, if you go like that, nothing. Even I don't understand anything when I read it. When I read it so fast. Everything you utter, you should understand in your mind. What your mouth says, you must try to follow that. So read it slowly. Literally like this. A polynomial of degree 1 is called a linear polynomial. And pause. Understand what you read. You heard something when you read it, that sound, you hear that sound. You must understand what that sound means. When the music plays, you know it is music. You understand that it's music. When a dog barks, when a cat mews, you understand that the sound is of a cat, the sound is of a dog, or a lion or a tiger or whatever. Or if it is music, or if it is some unpleasant noise, you understand because your mind perceives that. Same thing. See, so you make a sound, when you read, you are making a sound, you're making noise. A polynomial of degree 1, you're saying something, and that you should understand what you're saying. You should understand. So read it carefully. Ax plus b, go slowly. Read, understand the conditions. So the first time you read, maybe you still have it out. Do it again. Do it again. You will understand. So that effort you have to take. Everything we learn, is new. We're not revising something which you've already learned in the earlier standards. Every year you're learning something new. When you're learning, and to remember that See, understanding is one part. See, when I talk like this in the class, I believe all of you understand. But what you understand, if you want to register that, if you want to remember all that you've understood, you need to practice. That practice cannot happen in the classroom. Given to the vastness of the syllabus, that repetition cannot happen in the classroom. In the classroom, you learn, you get to learn many things. And all that is, explained in the classroom, you can remember only if you practice it. How many times to practice depends on the kind of person you are. It all depends. I can't say do it once, it's enough, do it twice. Do it 2-3 times maybe is required to register it, to put it in your long-term memory so that you never forget it. That initiative, that should always be there. As a student, that is your responsibility. Keep practicing. So read this theory slowly, children. Understand. Read it again. Another day, some other day, read it again. It will be clear. And again, some other day. How long is it going to take? 10 minutes? 15 minutes? That's all. Please, that repetition part you are expected to do. If you do not repeat, if you don't visit what you have understood, you will forget it. You have to keep visiting. Then you will not forget. All of you will do that. And certain advices, happens only a few times. I can't keep repeating this. Now take this. All that you understand, you will forget. If you don't want to forget, you have to practice. Repetition. Only by repeating you can retain. So take these two words, repetition and retention. Retention. If you want to retain everything you understand, you must repeat. For retention, repetition is very important. And if you have to repeat it, you should have understood it clearly. Who will visit something? If you have not understood something, how will you feel like reading it? You have not understood. How will you feel like reading it? So you tend to ignore a subject when you don't understand the subject. When you don't understand something, you don't want to do it because you've not understood. So please understand clearly in the classroom. Get your doubts clarified. When you understand, you don't hesitate to lift that book, to repeat it. And once you repeat, the more you repeat, the better you can retain. The more you repeat, the better you can retain. And if you can retain, you're a very happy person. You're very happy. You're very happy because you can remember so many things. You're so happy about yourself, and that reflects in your performance. That reflects in your performance. See, I always count. I say count on your efforts, children. Marks, out of 100. Only if you get 100 on 100 doesn't mean you're a good student. If you get 75 on 100, very bad. Next time try to get 100 on 100. No. I'm not a teacher who believes in this. Be happy with your efforts. Don't feel bad about your marks. If you've scored less, if you score 60 on 100, ask yourself, did you take the efforts to prepare for the exam? If you feel, yes, I did justice to my preparation, I did take efforts to practice, then fine, maybe you will do well. In terms of marks, you will be better some other day. Don't feel low. Marks don't decide what you are. Efforts are what says what you are. So you should not be guilty. You should not be guilty about your score. You must be guilty about your efforts. If you've taken less effort, then more guilt. I did not. I took very less efforts for the exam to prepare for the exam. Then you should feel more guilty. Why should you feel guilty? So that next time you correct yourself. So not all of us can get, so you're in a, you're attending some tuition class. So that means you should get 100 on 100. See, please tell you that is, I don't know if it's right to say, but that's not possible. Each one of us getting 100 on 100. Fine, I'll be happy. I'm not saying all of you in this class cannot get 100 on 100. I'm not saying that. That's not the way you measure yourself. Getting 100 on 100, very good. Very good. You got 100, very good. You got 70. Work hard. This is not enough. It's not like that. It's your efforts. So keep practicing. Work hard. You will be successful one day. Yes, I think we went away from math, so we can now continue. So far, what you've seen is we saw the standard form, linear polynomial, one variable x, linear polynomial, two variables x and y, and their conditions. When you equate to 0, linear equation. And two linear equations. Okay, so two linear equations in two variables x and y. This is one linear equation in x and y. This is another linear equation in x and y. Conditions. So one equation, one straight line. Two equations, two straight lines. They can intersect, be parallel or coincident. If you want to find the solutions to these equations, if you want to find the solutions to these two equations, you have the algebraic method, the graphical method. Algebraic method, you have three different methods: substitution, elimination, and cross multiplication. And we also have one more, which is called the special method. So now, tell me, who can tell me the standard form of a pair of linear equations in two variables x and y? Standard form, pair of linear equations in two variables x and y. Yes. Tell me. Yeah, don't hesitate. Simply unmute and say. There is no punishment for a wrong answer. Go ahead, children. Don't think so much. Just tap on the mic and start talking.
A1x plus B1y plus C1 and A2x plus equal to 0. A2x plus B2y plus C2 equal to 0.
Very good. Thank you, Ananya. All right, class, I hope all of you understand this, but we're only hesitant to say this. I hope. So now can you see A1, A2 here? Can you see A1, A2? How do you explain? How do you explain A1 and A2? Who's A1? Who's A2? Who's A1?
Real numbers, ma'am.
Okay, one more. How else will
Coefficient
Yeah, coefficient of
x.
x in the first equation. A1 is the coefficient of x in the first equation. What is A2?
Coefficient of x. Coefficient of x.
Coefficient of x in the second equation. What is B1?
Coefficient of y in first equation.
B2?
Coefficient of y in second equation.
Very good. And what about C1 and C2? C1 is the
constant in the first equation, ma'am, and C2 is the constant in second equation.
very good. Yeah, I think that's Nivedita. Very good. I think Meera also answered. No, sorry. I get confused with your mom's name and your name. Sorry. You are, what is your name? You are Leela, is it? No, I'm sorry. Please come again with your name.
Ma'am, I'm Meera.
Meera. Sorry, I'm very sorry. Yeah, Meera. So A1 and A2. A1 coefficient of x in the first equation. A2 coefficient of x in the second equation. Similarly, B1, B2, C1, C2 are the constants. Now you understand what is A1 by A2, right?
Yes, ma'am.
Yeah. And you understand what is B1 by B2. I think just finding the ratio. A1 by A2 is a ratio. B1 by B2 is a ratio. C1 by C2 is a ratio. See now like this. Now if I have the equations. All right. Now you have to compare this with A1x plus B1y plus C1 is equal to 0, children, because that is the standard form. A2x plus B2y plus C2 is equal to 0. Now tell me the value of A1. No, somebody was not, try to answer. Boys, I think I did not hear much from the boys. Hitesh. Are you there, Hitesh? Tarun?
Yes, ma'am.
Yeah, tell me, Tarun.
Ma'am, the value of A1x is 4x.
Yeah, what is the value of A1?
Ma'am, 4x, 4, ma'am.
4. What's the value of B1?
Mine bracket minus 6.
Very good. Minus 6. What's the value of C1?
1, ma'am.
Oh, sorry. This is 11. It's 11.
11.
11. C1 is 11. What's the value of A2?
6, ma'am.
6. What's the value of B2?
10, ma'am.
And what's the value of C2?
Minus 22.
Minus 22. Minus 22. Okay. Thank you, Tarun.
You're welcome, ma'am.
Murali, tell me what is A1 by A2? What is A1 by A2? Yeah, I'll come to you, Pranav. Murali, what is A1 by A2? Yes, Pranav.
Ma'am, it's 4 by 6, ma'am.
Simplifies to?
4 by 6, if we cancel 2 by 3, ma'am.
What is B1 by B2?
Ma'am, it's minus 6 by 10, ma'am.
Yeah, go ahead.
Ma'am, minus 10 by 6, if we cancel minus 3 by 5, ma'am.
What is C1 by C2?
Ma'am, see, it's 11 by minus 22, ma'am.
Yeah.
In 11 table, it comes 1 by 2, ma'am. Minus 2, ma'am. Minus.
Now we have the ratios, right? Okay, thank you, Pranav. You're right.
Yes, yes,
So,
ma'am.
children, now we have the ratios A1 by A2, B1 by B2, C1 by C2. Well, if you agree, we have the ratios, right? Because A1 by A2, so ratio.
Yes, ma'am.
Yeah, so we have some ratios with us. Now, I'm just trying to explain the heading. See, interpretation. I'm trying to explain what the heading means. Interpretation, meaning you are interpreting the nature of the lines by comparison of ratios. Break it up, break up the heading to understand the heading. Break up the heading. Interpretation of the nature of the lines. That is, you're trying to understand the nature of the two lines. How? By comparison of ratios. You're trying to compare the ratios and interpret the nature of the lines. Now, what nature of the lines? That is, if the lines are parallel, intersecting, or coincident. So our nature, we say, no, I'm very moody, or I'm a very jovial person. I never lose my temper. We have different moods. We have different natures. So like this, but these two lines have only three different natures. Either the two lines are coincident, or they are parallel, or they are intersecting. There'll be one of these three. So you interpret the nature of the lines. How? By comparing the ratios. We compare the ratios. What are the ratios? A1 by A2 is one ratio. B1 by B2 is one ratio. C1 by C2 is another ratio. These are the three ratios. We compare these ratios and we interpret the nature of the lines. That's what is the heading. Interpretation of the nature of the lines by comparison of ratios. So we have the headings again. Ratio comparison. Graphically, what it means graphically, what it means algebraically. That is your how it is graphically represented and the algebraic interpretation. Okay, somewhat you have understood what I meant. Now we have compared the ratios. We have compared the ratios. Now what do we understand here? A1 by A2 is not equal to B1 by B2. See here? What is A1 by A2? 2 by 3. What is B1 by B2? Minus 3 by 5. They're not equal. So when A1 by A2 is not equal to B1 by B2, the two lines are intersecting lines. See, now you will ask how. When we do the graph, when we solve, you will understand. I'll tell you again. When we work them algebraically or graphically, I'll show you. Now you just take it like whatever I'm saying, and you will see that it's true when we solve the equations. So without solving, we are saying we did not solve. See, we have two equations. We have this equation. We have this equation. We did not solve these two equations. We did not solve these two equations without solving. Just by comparing the ratios, we are able to interpret the nature of the lines if they will be parallel, intersecting, or coincident. Now, when A1 by A2 is not equal to B1 by B2, the two lines are intersecting lines. If suppose you have a situation where A1 by A2 is equal to, let me clear the slide. So this ratio comparison, you will have to find the ratios like this first, and then you have to compare. In our example, A1 by A2 is not equal to B1 by B2. In this example, A1 by A2 is not equal to B1 by B2. That means these two lines on the Cartesian plane are intersecting lines. When you make the graph of these two lines, they'll intersect in the Cartesian plane. In your graph paper, maybe they don't intersect. When you produce it, they will intersect. Okay. So if A1 by A2 is not equal to, if A1 by A2 is not equal to B1 by B2, we say that the two lines are intersecting lines. That means they'll have a unique solution. But this, whatever this point is, this point will have some address, no, x comma y. So that means the solution is a unique solution. The two equations. When we say a solution, it's a solution to the pair of equations. That is, it is that value which satisfies both the equations. We are talking about the solutions to the pair of equations. That is, we are talking about that point which will satisfy both the equations. So when A1 by A2 is not equal to B1 by B2, the two lines will intersect. And there is the point of intersection, and that will have some address, something like 3, 2, minus 5, 10. That is the solution. So it's only one solution, unique solution. Supposing A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. Supposing these two ratios are equal, but they're not equal to C1 by C2. Then like this is 5 by 6. This is also 5 by 6, but this is something like 2 by 3. A1 by A2 is equal to B1 by B2, but they are not equal to C1 by C2. In this case, the lines are parallel. When you make the graph, you will see that the two lines are parallel. That means they have no solution because there is nothing common. On this line, there are so many points. On this line, there are so many different points. There is no point common to both the lines, so no solution. The first equation alone has infinitely many solutions. The second equation alone has infinitely many solutions, but the two equations together have no solution. We are finding the solution to the pair of equations, not to the equations individually. We are finding the solution to the pair of equations. When you take this line alone, it has infinitely many solutions. This one alone has infinitely many solutions. But the solution to the pair of equations, both of them taken together, no solution. Why? Because there's nothing in common. This line has many points, this line has many points, but there's nothing common to the two. So no solution. Parallel lines means no solution. Intersecting lines, unique solution. And if A1 by A2 is equal to B1 by B2 is equal to C1 by C2, if all the three ratios are equal, this is 3 by 5, this is 3 by 5, oh, it can be minus also. This is also minus 3 by 5. In that case, if all the three ratios are equal to minus 3 by 5, that means A1 by A2 is equal to B1 by B2 is equal to C1 by C2. In this case, the two lines are coincident. Coincident lines. This is one line and this is the other line. One line lies on the other line. They are coincident lines. That means infinitely many solutions. Infinitely many solutions. Infinitely many solutions. What is infinitely many solutions? Because all the points on the first line are also points on the second line. Every solution is a common solution. So infinitely many solutions because every point on the first line is also a point on the second line. So all the points are common points. And how many points are there? So many points, infinitely many points. So infinitely many solutions. Graphically, when the two, so by comparing the ratios, so without solving, we did not make the graph. We did not make the graph. We did not solve it algebraically. Just by comparing the ratios, you can decide the nature of the lines. The nature of the lines can be decided without solving the equations. Just by comparing the ratios. So before you solve it, you know that it will have a unique solution or it will have no solution or it will have infinitely many solutions. Just by comparing the ratios, simply by finding. So easy to find A1, B1, A2, A1, A2, B1, B2, C1, C2. It's so easy to find them. Find the ratios, and by looking at the ratios, you can decide. See, for a pair of equations, there'll be only one answer. All the three you cannot get. Either they'll have a unique solution, or they'll have no solution, or they'll have many solutions. All the three is not possible. One pair of equations can have any one of these possibilities. If they're intersecting, that means they're not parallel, they're not coincident. If they're parallel, that's all, they're parallel, they're not this and this. One of these three is possible at a time. That's what you see here in this table. So you get the values A1, A2, B1, B2, C1, C2 by comparing the given equations with the standard form. So we'll see this again in the next class. Let's finish it. So intersecting lines, unique solution, coincident lines, many solutions, parallel lines, no solution. No solution. Now, let me just tell you about, these terms, consistent and inconsistent, and then wind up the class for today. Now, when the equations, that is when the pair of equations have, at least one solution. See, that is they have one solution or many solutions. The equations are said to be consistent. The equations are said to be consistent. The equations are consistent when they have at least one solution. At least one, so they can have many solutions also. So in the case of unique solution, that is one solution and many solutions, we say that the equations are consistent because they have at least one solution. Consistent, you can make a note of this. Just make a note of it somewhere in your book.
Yes, ma'am.
Consistent equations have at least one solution. Consistent equations have at least one solution. Inconsistent equations have no solution. Inconsistent equations have no solution. Consistent equations have at least one solution. Inconsistent equations have no solution. So when we see that a pair of equations have no solution, that means the equations are inconsistent. The two equations are inconsistent. We have two equations, right? The two equations are inconsistent. If there's at least one solution, we say that they are consistent equations. So consistent is if they have at least one solution. Inconsistent is if they do not have any solution. And we also have a special term here, see, dependent equations. Dependent equations is when the equations have infinitely many solutions. They're called dependent equations. You can see all the terms here. You can see it. See, why is this consistent? Because it has at least one solution, unique solution. Why is this also consistent? Because many solutions, infinitely many solutions. There is a solution, so consistent. And in this case where they have many solutions, they're also called dependent equations. Which one? Those two equations. Those two equations which we have, those two equations given, whatever, that equation just given. Those two equations are dependent equations when they have many solutions. And if they don't have any solution, the two equations are inconsistent. The two equations, the pair of equations are inconsistent. All right, children. This one we'll again discuss a little later, not in the next class, because we'll just work problems based on these, based on all this we have understood so far, and then we'll take up this, So children, is it fine?
Yes.
Okay, ma'am.
Any
Yes,
questions, children?
No,
No,
ma'am.
ma'am.
All right. Did anyone have the new students? Did you have any problem in joining the class?
No, ma'am.
Okay, so
No,
every
ma'am.
class a link will be sent like this. You just have to
Okay,
join the
ma'am.
class using. It's not the same link. You'll get a new link for every class, and you'll have to join the class using that link.
Okay, ma'am.
And new students, please share your email ID. If you have already shared, ignore it. If you have not shared, please share your email ID.
Okay, ma'am.
All right, children. So that's it for today's session. Thank you so much. Good night.
Yes, ma'am.
Thank you, ma'am.
Thank you,
Thank
children.
ma'am.
Thank you.
Thank you,
Thank
ma'am.
you. Good night.
Thank you, ma'am.
Thank you. Good night.
Ma'am, ma'am, should I send the class